Good morning, sir. My name is Nandini. Today my topic is recursive methods through object-oriented programming through Java. First, we are moving to the contents of recursive methods. First, we are going to the introduction to recursive methods. And next, types of recursion, applications of recursion, examples of recursion, advantages of recursion, disadvantages of recursion, and finally, conclusion of recursion. First, we are moving to the introduction to recursion. Recursion is a programming technique where a function call itself to solve a problem by breaking it down into subproblems. It consists of two main parts, the base case which stops the recursion and the recursive case where the function calls itself with modified arguments. Recursion is widely used in algorithms such as factorial calculation, Fibonacci sequence, sorting techniques like merge sort, quick sort, bubble sort, like this, tree graph transversals, depth first search, breadth first search, like this. And next, we are moving to the why we want to use recursion in programs. It is used to simplify the complex problems. It is used to reduce the code length, and the examples of recursion is factorial calculation, Fibonacci series, tree travels, and searching techniques like linear search and binary search, and sorting algorithms like bubble sort, merge sort, quick sort, like this. And then structure of a recursive method. First, we want to define the function. We have to create a function that will call itself recursively. And next, base case, specify the condition to stop recursion and return a value. Recursive case, call the function within itself with a modified argument. Ensure progress, modify the input in each call to move towards the base case. Return the result, the function should return the compute value from recursive calls. Handle edge cases, consider cases like negative numbers as inputs to avoid infinite recursion. And next, we are moving to the types of recursion. We have so many types of recursion, but there are four important recursions: direct recursion, indirect recursion, tail recursion, head recursion. And the first recursion is direct recursion. The function calls itself directly. And second one is indirect recursion. Two or more function calls each other in a loop. Tail recursion, the recursive call is the last operation in the function, making it more efficient, memory efficient. At recursion, the recursive calls happens first before any computation. And then applications of recursiveness. Base case and recursive case. A recursive function must have a base case to stop the recursion and a recursive case to break the problem into small problems. And after then we can solve it separately, and after getting the solution for sub problems and combine the all sub problem solutions, we get a main problem solution. Common in divide and conquer backtracking. Recursion is widely used in sorting like merge sort, quick sort, and bubble sort, and searching binary search, linear search, like this. Tree graph traversals, DFS, BFS, and problem solving like Sudoku and quiz problems, like this. And then example of factorial calculation. Uh, for example, in recursive methods, we have one example, that is factorial calculation. The source code is class fact. We have to define a class like fact int factorial of int n. If n less than 2, return n, else return n into factorial of n minus 1. And then we have to define another class fact demo. And then we have to define a main class, that is public static void main string args. Fact object equal to new fact, int n equal to new 5, int result equal to obj dot factorial of n. After then the output we have to print it. So system dot out dot println factorial of plus n plus equal to plus result, close. The output of source code is factorial of 5 equal to 120. And advantages of recursion is simplifies complex problems, because we have to we can divide the problem into sub problems, and we have to solve them in very easily, and then we can combine the solutions to get a main problem solution. Make it easier to solve problems like tree traversal, back tracking, and divide and conquer. Reduces code length, leads to cleaner, more readable, and shorter code compared to iterative solutions. Ideal for tree and graph problems, works well for hierarchical structures and travels algorithms like DFS. And then we are moving to the disadvantages of recursion. High memory usage. Each recursive call is stored in the call stack, which can lead to stack overflow if the recursion is too deep. Slower execution. Recursive calls add function call overhead, making them slower than iterative approaches in some cases. Difficult to debug. Tracing errors in recursive functions can be complex due to multiple function calls. If multiple function call a function, it is very difficult to debug because it get more errors. And finally, conclusion of recursion. Recursion is a powerful programming technique that simplifies problem solving by breaking problems into smaller problems after then solve the solution for them. It is particularly used in tree and graph traversals, divide and conquer algorithms, and backtracking solutions. And also it is used in sorting and searching algorithms, also sorting like bubble sort, quick sort, merge sort, and searching like linear search and binary search. However, recursion can be inefficient in terms of memory and execution time if not optimized properly. And then thank you, sir.